Welcome to AV4 Lesson 1. By the end of this, you'll be able to understand and use the vocabulary of spheres, cylinders, and cones. So let's first start by talking about cylinders. The axis is the segment connecting the centers of the bases of the cylinder. So the bases of the cylinder are circles. The axis would be from here to here. And many of you know this as the height. And that is true when we have a cylinder looking like this, but when we have an oblique cylinder, something like this, our axis still connects those centers, whereas the height would be over here because the height always has to be perpendicular to the base. If we have a right cylinder, the axis and the height are the same. The radius is the distance from the center of the base to the edge of the base. So from the center to the edge, that is the radius. So again, with the right cylinder, the axis of the cylinder has to be and is perpendicular to the bases. You're going to use this axis as the height. So this is your cylinder, just like think of a soup can or a pop can. This would be a right cylinder. So here the axis is going to be perpendicular to bases. In this case, this is your axis, and you can use this as your height. Again, that's in a right cylinder. In an oblique cylinder, the axis of the cylinder is not perpendicular to the base, so you do not use the axis as the height. So with an oblique cylinder, it looks like this. And the height has to be perpendicular to the base. So you'd be given something like that. Even with looking at the axis is not perpendicular now to the base. So you have to make sure that you do not use that in an oblique cylinder for the height. Now let's talk about a cone. So a cone is a solid composed of a circle. This is the base. There's just one of those. A given point not on the plane of the circle. This is our vertex. And all of the segments from that point to the circle are the cone. So here we have our circular base, we have our vertex, and we have everything in between. So with a right cone, the line connecting the vertex to the base is perpendicular to the base. You're going to use this line as the altitude or the height. In an oblique cone, it almost appears that the cone got smushed over. The line connecting the vertex to the base is not perpendicular to the base. Do not use this line as the altitude. Again, remember you will be given a line that's outside of it, that's perpendicular to the base, and that would be the height. A sphere is the set of all points in space at a given distance, which is the radius, from a given point, which is the center. It's kind of like a circle. Imagine that circle being three-dimensional. The circle is equidistant. You can think of that same idea with our sphere in those three dimensions being equidistant. Now we have a hemisphere, which is half of that sphere, and the important vocab word for the hemisphere is called the great circle. The great circle is the circle that encloses the base of the hemisphere. So it's down here. If you think about it, it's like the lid on the bowl. It's really that flat part. It's not part of the three-dimensional part. It is that flat circle on the bottom. Let's just transition for a moment to review a little bit about right triangles. These are all things that we learned in past units. Let's just recall that if you have any right triangle, we can use the Pythagorean Theorem to find any of the missing side lengths. Again, this is when we know that we have a right triangle. Then we have our two special right triangles. We have our 45, 45, 90, and I have given you those relationships again. We have x and x because those are going to be exactly the same. And then we have x squareds of 2, and we can use these special relationships to solve for missing lengths in a 45, 45, 90. And then finally, we have our 30, 60, 90 relationship. So if we know that our right triangle is a 30, 60, 90, we can use these relationships, x, which is across from the 30, x squared of 3, which is across from the 60, and 2x, which is across from the 90, to solve for missing pieces in this special right triangle. You will have some questions reviewing special right triangles on your practice problems, so always come back and take a peek at these if needed.